Hi, good day and welcome to empowermentfirst.college. My name is Abo Andfa Ephraim, and I will be leading you in the study of physical quantities and units. It is going to be our first lesson in physics, and I would like to encourage you to be free to ask any question anywhere you have problem or anywhere you find it difficult in understanding any of my concept. Please be free. Your inquiry will be answered as soon as you make them. Thank you so much, and once again, you're welcome. So, we are going to be starting with physical quantities and units. And the main objective is to to help you to understand um, how physical quantities and units are are used in our everyday life and why are they important in the study of physics. Now, I must say that this is the foundation of physics. This is the fundamental concept in the study of physics. And physical quantities and units are the key, are key basic. I mean, they are key, they are basic in the study of sciences generally. When I say science, I mean physical sciences. And in fact, the, in the study of science, it's very difficult to do without units and physical quantities. So it is. I mean, the lesson is very important um, in the aspect of science in our everyday life activities. Now, you must know that before you wake up, you have already carried out some measurement uh, in your mind um, of what you want to do maybe in the next few minutes. For example, if you want to walk from your bed to your door, you must have calculated um, a number of feet that you will reach there. So we call that distance. There must be at least some steps between your door to the bed. From your bed to your doorstep, there must be some steps that you take. So you see, that is distance. We're talking about distance. Now, let's say a physical quantity is a quantity. I mean, it's a property. It's a property of a material or a system that can be quantified by measurement. So basically, when we are talking about physical quantities and units, we are referring to measurement, which is very important. Now, a physical quantity can be expressed as a value, which is the algebraic multiplication of number, or maybe numerical value, and a unit. So when I say that a physical quantity is a property of a material or system that can be quantified, the term quantify, what does it mean? That's another thing. Um, when I was a college student, I mean in the university, sometimes I find it difficult to understand some terms, some scientific terms. So I tell myself, I told myself that I need a scientific dictionary. So I have to have a dictionary with me so that I can understand some of the scientific things. Because at that time, sometimes uh, I found it difficult. understanding some of them. So I will have to run a check. In mathematics and in empirical sciences or quantification, when we say quantification, it is the act of counting and um, measuring a map of human sense, observations, and experience into quantities. So quantification in this sense it's a fundamental um, to the scientific method. You know, so a physical quantity is a physical property of a material or system that can be quantified by measurement. A physical quantity can be expressed as a value, which is the algebraic term or multiplication of a numerical value and a unit. For example, the physical quantity mass can be can be quantified as n kg. Mass is measured in kilogram. So kg is the unit representing um, mass. So um, if we quantify mass as n kg, n will be the numerical value and kg will be the unit. So a physical quantity possesses at least two characteristics in common, and one is numerical magnitude, and the other is the unit in which it can be measured. Okay, so I'm going to put it down on the board. Let's say a physical quantity is a physical property is a physical property. It's a physical property of a material or system. Of a material or a system that can be quantified by measurement. That can be quantified by measurement. By measurement. So this is the definition of physical quantity. So the best thing is to understand the terms. If we're if we say we're discussing physical quantities, so the first thing we should know is to understand the definition of physical quantity. We need to know what physical quantity mean, then we will be able to discuss further. Now, physical quantities can have different sizes. Physical quantities can have different sizes. Um, we say some are scalar quantities. We say that some are vector or tensors. Okay, so let's say sizes. Physical quantities can have different sizes. Different sizes. Physical quantities can have different sizes, um, such as scalar, scalar, vector, or a tensor. Now, I'm going to define them one after the other. Now, scalars. What are scalars? Scalars, a scalar is a physical quantity that has magnitude but does not have a direction. A physical, a scalar is a physical quantity that has magnitude but no direction. Symbols for physical quantities are usually chosen to be single letter of the Latin or Greek alphabet and are printed in italic type. Well, let's try to remember the definition. Scalar we say that a scalar is a physical quantity that has magnitude but does not have direction. It has magnitude but no direction. But no direction. So I said that physical quantities can be of different size. It can be scalar, vector, or a tensor. So let's talk about, let me explain the word vectors. Vectors are physical quantities that possess both magnitude and direction. A vector quantity has both magnitude and direction, unlike a scalar. So vectors Vectors. Vectors are physical quantities that possesses both magnitude and direction and whose operations obey the axioms of a vector space. Now, symbols for physical quantities that are vectors are in bold type or they are undefined or with an arrow above. For example, if u is the speed of a particle, then the straightforward notation for its velocity are u or u with an arrow overhead. So let's see. I am going to write it down on everything I am saying here. We have a written script so that you can go through them at at your own time. So vectors have both both magnitude both magnitude and direction. So, like I said before, the best thing for you now is to understand the things first. Now, the symbols for physical quantities that are vectors are in bold type. Let me write that one down. The symbols for physical quantities that are vectors are written in bold. They are written in bold type. They are written in bold type and they are undefined or they are undefined or with an arrow above. Or with an arrow above on them. For example, let me show you. For example, let's say u is the speed of a particle. If u is the speed of a particle, then the straightforward notation for its velocity are u with an arrow cross. Then you have to write the straightforward notation arrow on it. A straightforward notation for its velocity. That's u, and this u should be bold. This is u, and then we have u. Now this represents our velocity. You know, it's either you write it on bold or you write it on the line or you write it with the arrow. You know, these are the way you can identify them, vector quantities. Now let's look at the tensors. This is for vectors. And then tensors. Well, tensors are scalars. Scalars and vectors are the simplest. They are the simplest tensors, which can be used to describe more general physical quantities. For example, let's say the Cauchy stress tensor possesses magnitude and direction and orientation qualities. Scalars and vectors are the simplest tensors. Are the simplest tensors. They can be used to generally describe physical quantities. To generally describe physical quantities. All right. So these are the basic definitions when we are talking when we want to talk about physical quantities. You know, we have to have this in mind always. We should remember the definitions. That way we can understand can understand better. Now, let's talk about unit and dimensions, but but that will be in the next class. As today we just discussed um, what physical quantities are. The next lesson will be unit and dimensions. So we shall be taking unit and dimension shortly after this class. So the next class will be about units and dimensions. Then, if we will finish units and dimensions, we will have a clear view of, of what I said about the fundamentals of physics. You will agree with me that physical quantities and units are the keys in the study of science by the time we are done studying units and dimensions. Thank you so much. Catch you soon.